Alright, it's just gonna start. I'm just gonna put it. Just get everybody's face in this. Oh.
Yeah. Rotate around.
Rotate. God.
I'm just gonna stand.
I'm just gonna stand. Yeah,
Yeah,
I'm just gonna stand. Alright, so we gotta do this 6 minutes and 30, basically. When I hit 6 minutes 30. Ready?
Hell yeah.
Alright, 3, 2, 1. What was the hardest or most unclear objective from the lab to you guys?
I don't know about hardest. I mean, maybe it was kind of hard, but it was so irritating trying to draw out the tangent lines.
Yeah. I think it was just so tedious, and it was
so
pretty.
tedious.
It was a much longer lab than our other
way.
ones.
I think this is probably the most time we've spent on a lab.
Oh yeah, we said that
For
last
sure.
week.
We said that
For
last week,
sure,
and now
yeah.
we're back here again,
Increasing.
saying the same thing.
Yeah.
It's slowly increasing the time.
Exponential increase in time
Exponentially
spent.
increasing time
I
spent.
guess.
But yeah, I agree that was probably the most unclear. I'd say was freehand drawing the derivative function. So yeah.
That's for sure.
Yeah, and then after the tangent lines, we had to draw the derivative, and then that became slightly unclear.
Yes.
And
Yeah.
excuse me. But yeah, overall very tedious.
Very
I
tedious
didn't
work.
enjoy that at all. But hey, now we're finished.
We're done. We're
We're
done.
done.
So the next question is, what was the easiest or most familiar learning objective from this lab?
Approximating tangent lines for sure.
Oh yeah, that was
just intersect it once
That was
and
cake.
make sure it's straight, and then you're good to
that.
go.
Just using Desmos, to be honest, that was like an easy part of the lab.
Yeah,
Where it was just asking
that's
us to use
just
Desmos and
plug
find the
and chug.
minimum and maximum.
Finding where it's increasing and decreasing.
Right. Yeah. It's
that's
like
something
it's
we-
just an eye thing. Like you
And
really
then
just
we
see
know
it.
that what is it? If it's like constant,
Uh-huh.
or if there's a maximum or a minimum, then the derivative will intersect zero. Like that was a concept that was rather easy. I was familiar with. No trouble there.
Right.
Nothing I found tedious about that. What else would I say? But, oh yeah, the other one is how like if it's increasing, it's positive. If it's decreasing, it's negative on the derivative. That's another part that I've was
Right, yeah.
familiar with.
Same. Yeah, tangent lines too. That was definitely pretty cake. I'm not
Yeah.
gonna lie.
Approximations are always easy. So as the exact answers tend to be a little bit more difficult. So
Yeah, no, that's one thing I'm really starting to notice. Like I can approximate all day, but like if we're trying to get an exact answer, it requires more.
more thought. And
More
Yeah,
thought,
yeah,
more
that's
thought
yeah.
for sure.
Definitely got to pay more attention to the steps that you're taking. But
Yeah.
put in more effort, and you get a better answer out of it. So it's
Exactly.
definitely worth it.
And the last question would be, what do you wonder about the lab concepts still?
Sticking with the theme that we have had the last few labs, applications, like how would you
Yeah.
use derivatives in real life to get meaningful data or just analysis? I'd say that's what I really wonder about most. So,
One thing I did notice when we were drawing the derivatives is there was a pattern that I noticed, like for that one that was like a W, that's I'm pretty sure that's like a x to the fourth, or like that's a fourth degree equation. The derivative of that was a third degree, and then I'm pretty sure we also did one where it was x squared or something.
Yeah,
like
expert.
And then it was just a straight line. Not like a straight constant line, but like
Right, yeah.
it was going down, so it was going down, then hit zero, goes up. It was a equation to the first degree, which the original one was second degree. I feel like there's some sort of pattern there.
yeah, there has to be.
For sure. Just like another question. Did you know like a different method to solve these types of problems like beforehand, or like
What do you mean?
because like one of the questions that it says here, it's like, did you previously learn a different method for solving a problem of this type?
No, you're good, man. It's good.
Did you so I have taken certain, like in high school, I have been taught certain calculus things, and I did learn some methods of like solving, like for example, if it's like a fraction, if it's being multiplied, stuff like that, there is certain methods that I still remember. Like, I think what I remember my teacher saying is like for the division one, it's like a really what do you say? The notation for it is really complicated.
Yeah.
So the shortcut she came up with was low d high minus high d low over low low, which is denominator times the numerator's derivative minus the numerator times the denominator's derivative, all over the denominator squared, which does ease out that process. And I know there are, I don't remember it off the top of my head, but I know there are a lot of like shortcuts.
Right.
Yeah.
And instead of doing the limit definition the whole time, I'm pretty sure there was one that when I said earlier about like how fourth derivative, the derivative is a third degree, the fourth degree, and then the one that's squared, the derivative is a straight line.
Right.
There was something related to that too, but I don't fully remember what it was. But yeah, I can't wait to relearn those shortcuts.
Right.
Yeah.
Right.
Yeah.
Yeah, some time savers.
Yeah.
Yeah, man, this might be our last lab since it's the end of the unit. So, like, for us, like, we're
Mhm.
probably gonna change all groups.
Yeah.
So, yeah.
Probably.
All right.
Good
Well, it's
luck
good
to you
working
guys,
with you
yeah.
guys.
Yeah. Good working with y'all.
All right.